Hello students, I am Sachitrakkar. Welcome to Cars Physics. This is my lecture 6 on electrostatics and we are continuing electric charge and electric field. In this lecture, we will discuss units of electric charge. So this lecture, maybe there is short video, but it's useful only for your fundamental standard, or you may say it's useful for your board standard. Again, the conversion of units also required while solving numericals. Okay, electric charge. Charge is a derived quantity in SI system. Okay. Charge is a derived quantity in SI system and units of charge in SI system, units of charge is Coulomb. Okay. And 1 Coulomb, as you know, current strength is defined as the amount of charge flowing per unit time. So I is equal to Q by T. So obviously charge is current into time, units of charge is Coulomb. We may write only C, and current is ampere, time is second. Okay. So dimensional formula of charge, from this you can obtain it. Mass to the power 0, length to the power 0, time to the power 1 second, and for current A to the power 1. Okay. Current into time is equal to charge. Two fundamental. Okay. But in MKS, not MKS, MKS-Q, in MKS-Q system, charge is a fundamental quantity. Charge is a derived quantity in SI system, and charge is in MKS-Q system, charge is a fundamental quantity. Okay, this much. Now we will know how to convert Coulomb into CGS units of charge. Okay, this is all about MKS-Q. If charge is taken as a fundamental quantity, then MKS system is extended to MKS-Q system. As we know, in MKS system of units, the fundamental units are length, mass and time, and the respective units are meter, kilogram and second. If charge is taken as fundamental quantity in MKS, then the system is called as MKS-Q system, where charge is a fundamental quantity and units of charge is Coulomb. Okay. Then in CGS, first unit is CGS ESU, electrostatics units. Units of charge in CGS is, we may write 1e.s.u of charge, or it may be written as 1 start Coulomb. Okay. Then under CGS, we may write CGS E.m.u. E.s.u, it stands for electrostatic units, and E.m.u similar electromagnetic unit. Okay. In CGS E.m.u, units of charge, we may write 1 E.m.u of charge, or it may be written as 1 absolute Coulomb. We may write it as 1 absolute Coulomb, 1 of Coulomb, 1 absolute Coulomb. So these are system different units of charge in MK.s.u, MK.s.u, and in SI and in CGS. Okay. Now conversion of charge, units of charge. Our first aim is to get 1 Coulomb, means in SI units of charge is 1 Coulomb, in CGS ESU units of charge is 1 start Coulomb. Okay. As we know, according to Coulomb's law, magnitude of force of attraction or repulsion between 2 point charges is given as K, Q1, Q2 by R square. Suppose these are 2 point charges. This is Q1. Let Q1 is 1 Coulomb. This is Q2. Q2 is 1 Coulomb. And distance between them is 1 meter. And medium is air. Okay. Then force between them, force is equal to K. K is in, we are taking in M case or in SI. Okay. K is 1 divided by 4 pi epsilon 0 into epsilon r. In air medium, epsilon r is 1 unit and force is 1 by 4 pi epsilon 0 Q1, Q2 divided by r square. And as we know, 1 divided by 4 pi epsilon 0 is 9 into 10 to the power 9. Again Q1, 1 Coulomb, Q2, 1 Coulomb divided by 1 meter square. Okay. And finally we will get magnitude of force is 9 into 10 to the power Newton in M case or in SI. Okay. Thus from this you can define 1 Coulomb. How can you define 1 Coulomb of charge? Very simple. 1 Coulomb of charge. 1 Coulomb of charge is that much. This charge is that much, which when placed in vacuum, air, or we may write vacuum, placed in vacuum at a distance of 1 meter from another point charge. This is also point charge, this is also point charge. Another point charge of 1 Coulomb, then it may attract or repel it with a force of 9 into 10 to the power 9 Newton. Too simple. 1 Coulomb and 1 Coulomb charge separated by a distance. These are 2 point charges, 1 Coulomb and 1 Coulomb separated by a distance 1 meter in vacuum. Then as we calculate, force between them is 9 into 10 to the power Newton. So 10 to the power 9 Newton. 9 into 10 to the power 9 Newton. So on the basis of this calculation, we can define 1 Coulomb. 1 Coulomb is that much of charge which when placed at a distance 1 meter in vacuum from another equal charge of 1 Coulomb, okay, then it may attract or repel depending upon positive or negative, okay, depending upon nature of charge, positive repulsion, negative repulsion, positive negative attraction. Then if 1 Coulomb of charge is placed at a distance 1 meter in vacuum from another 1 Coulomb charge, then it may repel or attract it with a force of magnitude 9 into 10 to the power 9 Newton. Okay. So this is about definition of 1 Coulomb. Similarly, we may define CGS, means ESU of charge. This is in M case or in SI. in CGS, CSU or start Coulomb. Let's consider here there is a charge 1 ESU or 1 start Coulomb, a point charge in SI. This distance is 1 centimeter and this is another point charge of equal strength, equal magnitude, 1 ESU. Okay. Then force again K, Q1, Q2 divided by R square, and as we know, value of constant of proportionality in CGS is 1 unit, then 1 ESU of charge into again 1 ESU of charge. Okay. 1 ESU into 1 ESU divided by distance is 1 centimeter square. Then force comes 1 into 1 into 1 divided by 1 means 1 dyne in CGS. In similar way, 1 ESU of charge we can define. 1 ESU of charge is that much of charge which when placed at a distance 1 centimeter from another equal charge of 1 ESU, then it may repel or attract it with a force of 1 dyne. These are two simple discussions and for your regular studies only. And as I have discussed, when I will solve numericals or discuss numericals, then at the end of the discussion means the last questions, some of the questions may meet the NEET and JEE standard, and at the end of the subject means a part of subject means units, will discuss completely competitive form questions. Okay, and finally we'll make or we'll discuss about one short video. Okay, then it's about CGS issue. Then now conversion. Let's consider in MK system, this is a charge 1 Coulomb, a point charge. This is another point charge of 1 Coulomb. Distance between them is 1 meter and medium is air. Then force is 1 divided by 4 pi epsilon 0. Q1 1 Coulomb, Q2 1 Coulomb divided by square of distance 1 meter square, and force is 1 divided by 4 pi epsilon 0, 9 into 10 to the power 9 Newton. Okay, so this is 9 into 10 to the power 9 Newton as we have already discussed. Then we have to know, or we want to know, 1 Coulomb is how much issue of charge, or 1 Coulomb is how much start Coulomb. Okay, let, we don't know, let 1 Coulomb is equal to x start Coulomb or issue of charge. Okay, then for the same situation, we'll now convert this force in CGS units. This force now will become, this is K, constant of proportionality, K, Q1, Q2 by R square. In M case, in air or vacuum medium, K is 1 divided by 4 pi epsilon 0. We are converting the whole form into CGS, and here in CGS K is 1 unit. Then to convert Coulomb into start Coulomb or issue of charge, we have assumed that 1 Coulomb is x start Coulomb. Okay, so 1 Coulomb is x start Coulomb. In place of 1 Coulomb, I can write x start Coulomb, again 1 Coulomb, x start Coulomb, divided by 1 meter square. In CGS, 1 meter is 10 to the power minus 10 to the power 2 centimeter. 1 meter square means 10 to the power 4 centimeter square. And finally we will get x square divided by 10 to the power 4. The units Coulomb, Coulomb, meter are converted to CGS, so finally force comes in dyne. So to convert means to equate with this value. Dyne may be converted to Newton. Okay, then force is x square divided by 10 to the power 4, and as we know, 1 dyne is 10 to the power minus 5 Newton. Okay, into 10 to the power minus 5 Newton, so this will come x square divided by 10 to the power 9 Newton. This is equation 2, this is equation 1. Now we will equate equation 1 and equation 2. See students, left side, force same, Right side. X square divided by 10 to the power 9 Newton is equal to 9 into 10 to the power 9 Newton. So Newton get cancelled, then x square is equal to 9 into 10 to the power 9 into 10 to the power 9, and finally x is square root of 9 into 10 to the power 9 into 10 to the power 9, and finally x is 3 into 10 to the power 9. Okay, and as we know, 1 coulomb, as we have assumed, we don't know, 1 coulomb is equal to x start coulomb. So I may write here 1 coulomb is equal to x, means 3 into 10 to the power 9 start coulomb or ESU of charge. This is conversion of coulomb to start coulomb, means we have converted into start coulomb, means in CGS ESU. Okay. Another form, you just remember it. This is very easier form, and what I have discussed or told you, these are useful for your regular studies and board-based questions. Okay. But the conversion is required for solving numericals. Okay. Then in CGS EMU, this is in start coulomb in ESU, CGS EMU, electromagnetic units, units of charge is 1 absolute coulomb. Okay, and simply just remember 1 coulomb is equal to 1 by 10 absolute coulomb. Okay, these are the two conversions. 1 coulomb is equal to 1 by 10 absolute coulomb, and 1 coulomb is 3 into 10 to the power 9 start coulomb. Again, you can equate and get another relation. 1 coulomb is 1 by 10 absolute coulomb. 1 coulomb is 3 into 10 to the power 9 start coulomb. 1 coulomb, equate right side. Okay. Then right side, 1 by 10 absolute coulomb or E.m.u of charge. Okay. This is start coulomb or ESU of charge. Okay. Then 1 by 10 absolute coulomb is equal to 3 into 10 to the power 9 start coulomb. Simplifying, 1 absolute coulomb magnetic unit, electromagnetic unit is equal to 3 into 10 to the power 10 start coulomb or ESU of charge. Okay. These are three conversions, 1, 2 and 3 applicable when we require conversion of units while solving numericals, and the conversion, the process of conversion is useful for your board standard or for your regular studies. So this is a very short lecture. Okay, I think you have enjoyed it, and these are two common studies. Thank you, students.